In today's lesson, we are going to be looking at solving factorable polynomials or factorable polynomials. So this is going to be taking the concepts that we've been looking at the past couple days, and we're going to be applying it to other polynomials similar to the ones that we've been looking at, but different. So for example, if we look at the first one, x to the power of 4 minus minus 11x squared plus 18 equals 0. This is different from what we've looked at before because this has an exponent 4 in it. Right? In most of the examples, or in all the examples that we've looked at, the highest degree or the highest exponent that we've seen is 2. Right? We've been dealing with what we call quadratics. Right? That's we had the whole lesson called solving quadratics. So this is going to be taking, like I said, taking those same concepts, but applying it to other types of polynomials. So what we're going to do here, looking at this example, we have x to the power of 4, we have an x to the power of 2, and we don't have an exponent. So we can see what's happening to our exponents is that they're increasing by 2 each time. Now, if we see that this is the case, there are kind of two ways that we can solve this. The first way, if we go through, I'm just going to let a equals x squared. So I'm just going to let a equal, I'm just going to pick any variable. It could be x, it could, or not x, it could be b, y, whatever you want it to be. We're going to let a represent x squared. So in this equation then, I can say, if I'm rewriting this, I could say it's x squared squared to kind of change x to the power of 4. 11 times x squared, and it's still plus 18 equals 0. And the reason that I'm doing this is because this looks very similar to a simple trinomial. So if I can get it to somehow represent a simple trinomial, I know how to factor those. So if I rewrite the above equation as this, right, I'm going to replace the x squared with a. So this becomes a squared minus 11a plus 18 equals 0. Now looking at this, this looks like a simple trinomial, right? We have a term squared minus another term, or sorry, a variable squared minus minus a variable plus a constant, right? This looks very similar to the x squared plus something x plus something. Right? So I can actually factor this as a simple trinomial, right? So the product and sum. So two numbers that multiply to give me 18, and two numbers that add, I think keeping consistent with our previous notes, and two numbers that add to give me negative 11. So because they multiply to a positive but add to a negative, we have to have two negative numbers. In this case, negative 9 times negative 2. Negative 9 plus negative 2 works out to negative 11. So I could rewrite this as a minus 9 times a minus 2 equals 0. Now what I can do, now that I factored this, now I can replace a with x squared. So all I'm doing is I'm just basically putting it back in, right? So I took it out, I've removed it, or I've replaced it with a placeholder, and now I'm putting it back in. So now we get x squared minus 9 times x squared minus 2 equals 0. Now I can solve this, right? We talked about it before in the previous lesson. In order for this to work out to 0, either the first bracket or the second bracket has to equal 0. So x squared minus 9 equals 0, and x squared minus 2 equals 0. So if I move the 9 over, this becomes x squared equals 9. I want to take the square root of both sides, so x equals 3. But technically it could be plus or minus 3. We're talking about when we take the square root, I could have 3 times 3 or negative 3 times negative 3, which would give me 9. So when we square root both answers, or when we square root the answers, we actually get plus or minus whatever the value is. And for the other one, x squared equals 2. Take the square root of both sides. I get x equals plus or minus the square root of 2. So I get two possible answers. So therefore, in the end, x could equal, it's either plus square root of 2 minus the square root of 2, 3, or negative 3. So we get multiple possible answers. So that's the first way that we could do it. The second way is still doing something similar. It's still the same idea, except it's just recognizing kind of a pattern. So the second way, and we'll just kind of do this shortly and I'll move it over or erase it, is if I look at this polynomial, x to the power of 4 minus 11x squared plus 18 equals 0, you might look at it and say, okay, well, this is close to a simple trinomial. And well, when I come up with a simple trinomial, the first term in each bracket has to multiply to give me this. So whatever this is and whatever this is, if I multiply them, the answer works out to that first term. So if I think about, okay, well, what times what gives me x to the power of 4? That's x squared. Right? And it kind of fits in the pattern, right? Because of a simple trinomial. So then we look for the two numbers again, then multiply to 18 and add to 11, which is minus 9 and minus 2, which gives us the same answer, right? Or the same factored form. And you can think of it, because looking at it, or looking at what we dealt with in quadratics, it was x squared, we'd say plus bx plus c. So the main thing is looking at how do these two variables relate. Right? X squared and x to the power of 4, x to the power of 2, right? Looking for that kind of pattern. So again, there's just two different ways you can think about it. I would think about it kind of maybe as factoring or kind of substituting out and replacing variables. That might be easier, or kind of recognizing some of the patterns. For B, 6x to the power of 4 minus 5x squared minus 4. So this is similar to the previous one. This is looking at this form. There's three terms, so it is a trinomial, but it's not the trinomial that we've kind of dealt with before, right? Usually we see x squared, x squared, ax squared, say plus bx plus c. We see something similar, except in this case we don't, right? We see x to the power of 4 and x squared, but it still has the same pattern, right? So if we want to, we could go through the same steps as before, right? Let a equals x squared. So I have 6, just rewriting what we originally had to show how if I replace x squared with a, how it does now look like a complex trinomial in this case. So I can go through and solve this as a complex trinomial. I'm going to use the product and sum rule, as we did in class. I think this is the way that you preferred. So two numbers that multiply to, two numbers that add to. Because it's complex, it's not just the last number, it's 6 times negative 4 or negative 24. So two numbers that multiply to negative 24, but add to negative 5. So because we're dealing with multiplying to a negative and adding to a negative, we should have one positive and one negative number. Thinking about this, it would be negative 8 and positive 3. So negative 8 plus 3 is negative 5. Negative 8 times 3 is negative 24. So now I can rewrite this as 6a squared, say minus 8a plus 3a. So similar to factoring complex trinomials. Minus 4 equals 0. I'm going to factor by group, or common factor the first two and the last two numbers. So I end up with 2a times 3a minus 4. And if I just take out 1, I get 3a minus 4. So the same thing, which is our goal. We want to get the same bracket. So then I can factor out that bracket. So factor by grouping. So I get 3a minus 4 times 2a plus 1. And now we're going, or equals 0. And now we're going to replace a with x squared. So now we're going to bring it back in. So we get 3x squared minus 4 times 2x squared plus 1 equals 0. Now that we've factored it, we can set each bracket equal to 0. So 3x squared minus 4 equals 0. 2x squared plus 1 equals 0. And solve for x. So we're going to move everything over first and then take the square root at the end. So 3x squared equals 4. X squared equals 4 over 3. Take the square root. X equals plus or minus the square root of 4/3. We do the same thing for the next one. Move over everything except for the square root, and then deal with the squaring. So we become negative 1. We get x squared equals negative 1 over 2. X equals plus or minus the square root of negative 1 over 2. However, we should recognize that if I try to take the square root of a negative number, there's an error, there's no solution, because I can't take the square root of a negative. So therefore, x is equal to plus the square root of 4/3 and negative square root of 4/3. So negative square root of 4/3 is different because it's take the square root of 4/3 and then make it a negative number. It's not the same as taking the square root of a negative. It's different. But again, that is one other method, or again, that's another example where we are factoring a polynomial that is not a quadratic, but it shares similar properties or characteristics of some of the quadratics that we've dealt with. And again, only in these questions, you're only going to be able to solve them if they are factorable. So it's more about checking to see if there's some relationship, looking for patterns, looking for characteristics, and looking for examples similar to this. I wouldn't give you a polynomial that you couldn't factor and ask you to solve it, at least not by hand. Right, so the next one we see here, x cubed minus 21x squared plus 54x. So this is similar to what we've done, or similar in the idea that it's a quadratic, or it's a polynomial. It is going to be factorable. And looking at this, we see that every term has an x. So let's common factor that out and let's see what we get. So if I take a common factor of x out, that leaves x squared minus 21x plus 54, all equal to 0. Now in the bracket, it looks like a simple trinomial. So I can actually factor that bracket as a simple trinomial. I'm going to do the product and sum. So two numbers that multiply to give me 54, two numbers that add to give me negative 21. So because they're adding to a negative but multiplying to a positive, I should have two negative numbers. So in this case, I end up with negative 3 times negative 18. So negative 3 plus negative 18 is negative 21. So that means then these two brackets become x minus 3, x minus 18, all set equal to 0. So this is a little different now. Before, we've dealt with just two brackets, and they had to set equal to 0. Right? We set each of them equal to 0 because if I'm multiplying two things, in order to get 0, one of those two terms or one of those two numbers or values has to be 0. Here I'm multiplying three things. I have the x multiplied by the x minus 3 multiplied by the x minus 18. So I have three things that are multiplied together and they have to equal 0. Well, how would that work? Very similar to what we've done before, except instead of one or two of those values or terms or brackets equaling 0, one or three of these can equal 0. So I'm going to set all three of these equal to 0 separately and then solve. First one's easy, x. Let's set x equal to 0. I've solved it. Don't have to do anything more. X equals 0. Let's take the next one. X minus 3 equals 0. This one's a little bit, one extra step. I wouldn't say it's more challenging, but we do have to do one extra step. Move the 3 over, it becomes x equals positive 3. So that's another solution. Next bracket, x minus 18 equals 0. Move the 18 over, x equals positive 18. So therefore, I have three possible solutions for this one. I have, so x could equal 0, 3, or 18. Those are the three possible solutions that I could have. And 3 shouldn't be too uncommon because we did look at one in the first example that had 4 possible solutions. So we have seen more than 2. Yeah. Next one, D, I have 4 terms. 2x cubed minus 6x squared plus 5x minus 15. If I have 4 terms like this, factor by grouping. So factor by grouping, which is, and then when you factor by grouping, you're essentially common factoring, which we have done before. We've done this when we've solved complex trinomials. We've factored by grouping. We've factored, essentially you're looking at the first 2 terms, the next 2 terms, and you're common factoring each of those. So if I look at the first two, 2x cubed minus x to the power, or minus 6x squared, I can take out a common factor of 2 from both, as well as an x squared. So I'm then left with x minus 3. In my second pair, 5x minus 15, I can take out a 5, or a positive 5, and that would leave me with x minus 3. We should recognize then that we have 2 brackets that are the same. X minus 3, x minus 3. So I can take, set that equal to 0. I can take that bracket out as a factor, x minus 3, and the remainder would be 2x squared plus 5. So I can common factor out a bracket between those 2 terms. The remainder, in this case the 5 plus 5 and the 2x squared, becomes my second bracket. So now I have x minus 3 times 2x squared plus 5 equals 0. What I can do now is set each of those brackets equal to 0, because again, it's one term or one polynomial multiplied by another polynomial. In order for that to equal 0, either the first or the second bracket has to work out to 0. So in the first one, x minus 3 equals 0. X equals 3 because I moved the minus 3 over. The next one, 2x squared plus 5 move or equals 0, move the 5 over. So 2x squared equals negative 5. Divide by 2. I get 2 or x squared equals negative 5 over 2. And then x equals plus or minus the square root of negative 5 over 2. Ooh, there's a little bit of a problem there. Taking the square root of a negative. Is that possible? Can I get the square root of a negative value? No, I cannot. So because that's taking that square root of that negative, there are no solutions to this portion. I still have a solution up over here, x minus 3, so therefore x equals 3 is the solution or the only solution for this equation or for this polynomial. One last example, 3x cubed minus 9x squared minus 2x plus 6. Again, we're going to do the same thing. We see 4 terms here, so we are going to factor by grouping. We're going to factor the first 2 terms, factor the second 2 terms, and it's just common factoring. So if I look at the first 2, 3x cubed minus 9x squared, I can take out a 3x squared, and I'm left with x minus 3. In the next one, I can take out a, now this is where factoring by grouping can get a little tricky, right? You might say, well, I'm going to factor out a 2, right? A positive 2. That's all I can take out. That would leave me with negative x plus 3. Remember, when we factor by grouping, our goal is to make sure that these 2 brackets are the same. Right now, they're not. One is almost the same, it's just off by a sign. So what we can actually do is actually, instead of taking out a positive 2, let's take out a negative 2. That would make it x, and that would make it minus 3. So you might have to do that. That's the one danger. Or what the one complication of factoring by grouping. You do have to go through and kind of make sure that you common factor to get the same brackets, right? Because now what we can do is we can common factor out that bracket. We can common factor out x minus 3 as a whole. That leaves us with the remainder, which in this case is 3x squared minus 2. That becomes our second bracket. That's still all set equal to 0. Now I can go through and solve. So I factored it. I factored the polynomial. I've broken it. I have my 2 factors. I can go through and solve. The first one, x minus 3 equals 0. Move the 3 over. X equals positive 3. The next one, 3x squared minus 2 equals 0. Move the 2 over. Get 3x squared equals 2. Move the 3 over or divide it. I get 2/3. And then finally, I take the square root of both sides. So x equals plus or minus the square root of 2/3. So this means then that therefore x can equal 3 positive square root of 2/3 or negative square root of 2/3. So 3 possible solutions for this polynomial. Lastly, some things we're going to look at just because it's going to be helpful as we move further along with polynomials. Just some general terminology. So if we come across a polynomial that says ax plus b, this would be something that we call linear. Right? This is very similar to y equals mx plus b, which you probably had seen before. This is a linear function. If we have something that is ax squared plus bx plus c, when we expand it, right, I should put that in brackets. This is all expanded. This would be what we consider a quadratic. So we should be familiar with those 2 terms. quadratic, linear, those are the two kind of functions that we've dealt with before. If we have one that's ax cubed plus bx squared plus cx plus d, this is something that we would call cubic, a cubic function. And the main difference here, or the unique characteristic, is this exponent of 3. The next one, again, kind of following the same pattern, ax to the power of 4 plus bx cubed plus cx squared plus dx plus e. This is what we would call a quartic function. So a quartic function. And again, the main characteristic of this one is the exponent 4. In the next one, it's the same idea. We're adding a term. We're increasing the exponents. So this one has an exponent 5. There are specific terms for these different polynomials. But when we get above 4, we would say it's a polynomial of degree 5. And the reason we say degree 5 is because when in the expanded form, it is the highest exponent that we see. So in this case, the highest exponent would be a 5, so it's considered degree 5. Technically, we could say polynomial of degree 3, polynomial of degree 4, polynomial of degree 2, or degree 1, but for the first 4, which we'll most likely be seeing, especially when we in these factoring or solving by factoring, we would mostly see the first 4. We will see ones with the degrees higher than 4 in some future lessons, but it's going to be a little bit different, right? So in terms of factoring, just think of the examples that we've seen. Kind of focus on those types of problems, looking for those different patterns or characteristics that we talked about.